coming up this week on Let's Make It, this is week number 2 of our shift registers, and I actually have a special guest via Skype ready to come on and talk about shift registers. So just hang in there. We'll be starting up in 1 minute. Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello and welcome to episode 18 of Let's Make It, and this week I actually have a special guest I'm going to introduce in a second. Last week we talked about shift registers, and this was all because of my guest. It was all his idea, and appreciate all the effort he's done with this. So before I go too far, I want to introduce you to Bob. This is Bob Powell.
Hello.
How's it going, Bob?
Very good.
So you're in the great state of Texas, right?
That's right, Dallas.
All right. So you're in the nice warm area of the country right now.
It's very nice today.
Very nice. All right. So last week we talked about shift registers, and this was an email I got from Bob. He wanted to know if we'd cover those, and actually he didn't need me to cover it. I needed him to cover it because he knows them much better than what I do. And this week we're going to take that same shift register concept, and we're going to add an additional chip to it and show you how it can work by adding or by serializing basically more chips on there. And Bob has some stuff set up. He's going to demonstrate as well on different types of chips as well. So Bob, I'm going to kind of let you run with where you want to go with this.
Well, let's. You were working with the 595 last week, and I think the next code example was the one that had several LEDs or several shift registers all connected.
Right, and actually I took the code, your code for one, and made it work with really simply for two as well.
That's right.
With very little changes.
Yeah,
and I have that running right here next to me as well. Okay,
then that's probably a good place to go.
All right, let's go look at the mess I have sitting here next to me. The colorful spaghetti code right here, and it's a little hard to see. The lights that are LED lights. I wonder if I turn this light off on my head, if it helps or not. Yeah, let me do that real quick. Let me see if that helps. Does that help some? Yeah, it helps a lot, actually. All right. So what we have here is LED strip lights, and each of these little boxes has 4 LEDs in it. So this whole square right here has 8 LEDs. So what I basically have is 8 LED strip, which is what we had last week, and I've added a second one to the other side. And if you go up here to the top, you see I actually have 2 chips, lots of wires covering them up, but there's the same chips we used last week, just 2 of them. And I'll put up on the show notes the drawings for all this as well. So the program that's running is actually Bob's program that we looked at last week. And in the very beginning, he has the ability to say how many LEDs you have, and this program pretty much does everything else from that point. So you can see it's going to walk through all the same examples as we had last week, just with a longer LED string. And you can jump in anytime there, Bob.
Okay, well, this code that you're using is the one that that I wanted to get to, because it's written in a way that you can string quite a few LEDs or anything else to the shift registers. And the shift registers themselves, the library that pushes the data out, if you're using LEDs, you're probably limited to about 20 shift registers, which would give you
Like
what,
160? Yeah,
160 LEDs. If you're running something a little slower, theoretically, I think the library supports 2,000 something. But at 2000, you're going to have signal problems. You're going to have you've got some circuitry problems that you're going to have to work on. But the library itself will support that many shift registers at once.
So what's the limitation as far as number of shift registers you can have?
There is a physical limit that they've got hard-coded into the library. I'd have to go back and look at it. When you're stringing that many shift registers together, the latch and the clock are all connected to the same pin. So if you're just using a few shift registers on one 5-volt clock or latch, you're not going to have any signal problems. But when you've got 100 of them out there, well, then you're sharing the same 5 volts with that 100 shift registers. So you're going to have to do something to the circuit to either put a transistor, put a MOSFET, something like that. So you're not running all of that current off the Arduino, because it's not going to support that much current, and you're going to lose a little bit of voltage across the entire span of shift registers. So
now, in kind of pre-show, we talked about the timing issue as well. Can you explain that one a little bit as well?
That's right, because one shift register, what you're doing is you're clocking in. And the documentation that I've found, I haven't tested this, it's running at about 1 megahertz out of the Arduino, because the library has a lot of overhead. So you're not getting 16 megahertz clock speed that you would get that the Arduino itself is running at. So it takes about 1 millisecond to push the data out to 10 shift registers. So that's why you're limited to about 20 shift registers for LEDs, because that would be 20 milliseconds. Well, that's 500 hertz, and most people are running, they're manipulating their LEDs fast enough that 500 hertz for data, you've got to be able to support that. So I think the library could be modified, but I haven't dug into it that much. Because for the examples that we're doing here, running everything off the Arduino with 2, 3, 4 shift registers works perfect.
Good. All right. And I think I mentioned this last week, but I want to make sure we cover this. You can use this for more than just lighting up LEDs. If you had a large bank of relays or some other kind of control, it's an easy way to control large number of things with very few pins.
That's right. And I think you've got that. I think you've got that example.
Yeah. Yep. I do. Okay. So you had done some things on your side too that you were showing me earlier. Do you want to do a little show and tell?
Yeah. The chip that I have. Let me switch to the other camera. This is the same code that you have running on that shift register, and that's the nice thing about if someone can master a 595, then there's an infinite number of possibilities. The chip that's running here is a single Maxim. It's the Max 6971, which is a 16-bit sync driver, which basically means instead of manipulating the anode side of the LED like the 595 is, it's manipulating the cathode side. The great advantage is, and I don't know if you can see it in there, there is a single, one single resistor for the whole thing. Let me
don't really see it in there, but I believe you.
It is right there.
Oh yeah. Okay, I see it now.
So rather than having 16 resistors connected to each one of your LEDs, well, you can run all of them off of one resistor for the whole thing. Again, it's multiplying just a little bit of information and making it far more efficient. And one thing I did discover on this, this code that's running is the exact same code that you're using on your LEDs right now. There is one addition, and I discovered that this week. This right here is pin number 3, which is one of the PWM pins, and this chip is fast enough to support PWM. So what you're looking at is roughly a 10% duty cycle. And I turned it way down to, so because of the light was blowing out the camera.
Right. So I think we want to explain a little bit about the PWM and what it's doing, just in case somebody doesn't understand how we're using the PWM. PWM is pulse width modulation, and in this case, we're using it to control the brightness of the LED, right?
That's right. And so this is running at roughly 500 hertz. So it's flashing. It's actually flashing the LEDs on, or the entire array of LEDs 500 times a second, but it only turns them on once out of every 10 cycles.
Okay, so it basically is 50 times a second it's turning off and on.
That's right.
And you can adjust that by the PWM, using PWM off the Arduino.
That's right.
It looks like you can do some brightness change right there, right? Is that what you're doing?
Yeah, that was a signal where I start off at maximum intensity and go back down to 10%, and then go from 10% back to max. And then the sequence that we're watching right here is running at 10%. That way we can actually see it in the camera.
Right. It's the problem I have here. That's why I went to the yellow lights thinking it'd be better this week, but because the blue ones last week were just too bright.
Now that right there is it's a function called busted, which is in honor of my police officer son. Did you see that one?
Yep.
Okay.
And I saw you yesterday. I think you had colored ones in there as well.
Now I'm working on I've used the same basic code on a Texas Instruments TLC 5940, and I've got RGB LEDs connected to it, and I've got 3 of those running RGBs. So I don't actually have that on right now, but I. All
right. So you had sent me some videos. Do you want me to play some of those videos?
Yeah, let's. LEDs are nice and fun, but the relay one is really where you get to something useful.
All right. Let's see. Do you know which number video it is that you sent me?
It is 2118.
2118. All right. So while it's doing this, you want to talk through it?
Well, it's the same sequence as what you have, only the code has been switched to 1 shift register and 8 LED. In the code it says LEDs, and this is the same sequence. Now, what is a little odd about this is that the red lights that we see on right there, that actually indicates the relay is off. So when you see all red, but it's the same sequence.
Right, so you're running the same program and everything we had before, just now you're controlling relays versus controlling just an LED.
That's right. And what you see right there, that is I'm using a random function on the Arduino to randomly turn on and off the lights, which is Christmas lights. So that code right there is Christmas lights.
All right, well, that's neat.
Now, a couple things about that, running that LED, or running the relay, that pretty much maxed out what the Arduino could do.
Power-wise?
Power-wise.
Right, okay.
It would have been better, well, if somebody were to do a 16-channel or several 8 channels all connected to multiple shift registers, they would have to go to some sort of power, not running it directly off the Arduino.
Yeah, so you're actually powering the relays off the Arduino in that case.
That's right.
Yeah.
Just because it was convenient, yeah.
Yeah, and I had that problem with the big LCD displays and running, I remember what it was. I had something that was like you could tell when it turned on. Oh, it was the RFID. Every time the RFID would power up this display with dim downs. I was like right on the edge of what it would take.
Right. Yeah, and we were right on the edge. And the only way that would work is if I were running a external power supply. I couldn't run it off of USB only.
Right. Right.
Because you don't deliver a full 5 volts to your components if you're running off the Arduino.
Right.
Or running the Arduino off USB. I'm sorry.
Right. The USB isn't powerful enough for that.
That's right.
Do you want me to do any of those other videos that you sent me?
Well, it's kind of the same sequence. The
Okay.
you know, that's kind of the point in these demos it's changing the setup and being more efficient about your code. So the code that you're running right now, it's the same sequence as what we've been looking at, but you could string up 20 of those things,
right,
if you wanted to.
Exactly.
And that's the nice thing about that's the nice thing about shift registers is you master it and you can do a lot of things with them.
Right, and actually last week I did a wiring diagram. I did a schematic for it, and I have one for the two together. I'll put that up on the website as well. I even put up a board design if you wanted to like get a board printed somewhere and play with it, because it's a little hard with all the wires everywhere. Just a little bit easier. I was hoping I had them by today, but I didn't get by yesterday. I didn't get the boards in yet. But it'd be a little easier to demonstrate because the wires wouldn't be there.
Yeah, the wiring on these does get a little dicey sometimes. Yeah,
it's lots and lots of wires. You got, in my case, I had two 20-pin chips. Of course, 2 of them are not connected, so 18 pins off each one of them going somewhere. And so connecting these two together, we shall probably, I think you might have mentioned this, but basically you're putting together the clock and the enable, and then you're also taking data out or serial out of the first chip into the second chip.
That's right. And in my case, I was using a TI chip, and the data all goes into you daisy chain them together. They're just in series, and you tell the Arduino which pin is the data in, and then on that first register, there's a data out pin, which goes into the data in of the next shift register. And then the data out of that one goes into the data in of the next one. So you just daisy chain them together until you're done. And then the clock and the latch pins are all tied together to the same 5-volt source off the Arduino.
Right. And one thing that had happened to me, which I probably should mention, was when I first started playing with it, I had the 2 chips together, and I wasn't sending out 16 bits, I was sending out 8. I couldn't figure out what was going on. The shift out only sends out 8, so if you have 16, you got to do shift out twice on the Arduino, if you're using the Arduino code at least.
Yeah, the Arduino library that comes standard with the software will support 2 bytes. So it will support and they call it low byte and high byte.
Right.
And that's it. And that's why for the code that's got N LEDs, N being any number of shift registers, that's why I switched libraries to support essentially an infinite number of shift registers.
Right. So I guess we kind of want to talk about that too. The Arduino itself only handles 2 bytes. If you want to go longer, there is a library out there, correct?
That's right.
And where can I get that from?
It's documented in the source code, and I know you've got that in the show notes.
Right. I'll have a link to the source code again on this show as well.
Right, because it's all linked. The source code is out there on GitHub. It's available right now.
Very good.
Now, one thing about the 2 little details about the 595 that we haven't talked about is there is a master reset and an output enable pin. And one of the really nice things about a 595 is that not only can you bring data in, but you can also send it, or we're using it to send data out, but you can also receive data back from a 595. And there is a pin called an output enable pin that lets you switch back and forth between input and output. Now, in our example, we're just doing output. We're not inputting any data. But if you had digital data, you know, from a sensor or a switch, or you could receive that data off of a 595.
Yeah, I haven't done that yet. I need to play with that. That'd be a neat way to get sensor data back in.
That's right. So again, it's multiplying what you do. But in our case, because we're not switching back and forth, that output enable pin, which is, I'm looking at the data sheet, it's pin 13, has to be tied to ground. It has to stay low. To switch it to input, you've got to send that pin high.
Okay.
And
so
then,
when you do that, do you basically clock in and it just constantly reads the input pins like 8 bits at a time?
Well, it reads things just like you send data out. You're clocking it. You have to use your clock pin and switch your Arduino code to receive digital input.
Right. Okay.
There's also a master reset, which is the pin 10. If that pin goes, I've got it tied to 5 volt. If it goes low, you essentially clear out everything.
Right. I think I even saw some examples where they were tying that to a pin on the Arduino and in code clearing it out.
Right. And if you were switching back and forth between input and output, that would be an important. That wouldn't be an important thing. But for what we're doing, all we're doing is pushing data out to LEDs or relays or some some output. That just needs to be tied to 5 volts because we're never going
to leave it that way. Yeah, that's how.
If you leave it floating or tie it to ground, then you won't have any output.
Right. Okay. All right. Well, this has been interesting so far. Now we're not done with this stuff either. Really, we have you have 7 segment displays like I do, and there's essentially the same thing.
Yeah, I wanted to do a 7-segment display, and I got it out today and discovered that it was bad.
Yeah, we can do that on another episode. But I mean, they work in a very similar fashion. You basically have a driver that you give it the information with very few pins, and it does all the work for you.
Well, essentially one 8-bit the 595 that we're using will drive a single 7-segment display.
That's right. Yeah, just because all it is seven LEDs.
That's right.
And it's when you get the multiple segments that the drivers sometimes help, because they'll kind of like you're doing with the pulse width modulation is they keep switching between the numbers really fast and turning off and on the LEDs. That's the thing you can't tell that they're doing it.
Yeah, that's right. I mean, you could do that yourself if you were tying, I mean, you could do it yourself, but yeah, the multiple display, it does it for you.
Right. That's the nice thing about the drivers. They take a lot of that work away from you. So there was also matrix display drivers, which I have some that I haven't played with that are also very similar to using a shift register. And actually, you could take a shift register and do the same thing with a matrix display, kind of like you're doing with your LEDs.
Yes, you sure can. Same concept. It's all multiplying the efforts. The matrix displays, it's tying the pins to them and just tying them high and low. So, yeah, you can turn on and off. Anything that you can use. Where you need a digital high or low, you can run through a shift register.
So how are you doing your multiple color LEDs?
On that one, I'm using 3 16-bit channels, and I've got them. I've got 16 RGBs connected to 3 16-pin 5940s.
So it's actually a 4-pin LED.
It's a 4-pin LED. I'm using common anode. The 5940 does not work with common cathode. It only works with a common anode. And then I've got it close to There's one function that I've got, I'm not quite sure what's going wrong. I have an idea, but I've got most of my code, the same code that we've been using. And if you'll give me just a minute, actually I can switch to it. Okay, now this one, now there's busted, but now it's flashing blue and red. So this one of the nice things about this is the data itself is actually being pushed out just like any other shift register from one chip to the next to the next. So it's conceptually it's exactly the same.
Right. Yeah, I wasn't sure if you're using, because the LEDs you can go two different directions with the voltage to change the color. So you're using a 4-pin LED, each basically individual LED.
That's right. And one of the there's a couple nice things about this 5940. One is that there's what's called a dot correction on the chip, which means you can, if you've got a chip that is exceedingly bright, then you can dial that single LED down with the chip's dot correction. Or if you've got a couple of chips that are dim, you can dial the bright ones down so they all match. So that's one nice feature. The other one is that each individual LED has a 12-bit PWM on it. So you can really dial in the shading of an RGB. Now, to get this camera to work, I've actually turned the dot correction. It's a 6-bit dot correction, so you've got 0 to 63 as your settings. This is actually setting number 1 to get it to look right on the camera.
Oh, so that's the dimmest it can get then.
That's the dimmest it can get.
That's actually pretty amazing.
So now the setup is a lot more complicated on a chip like this than a 595, and it actually takes five pins to control the chips, and you can see the mess of wires.
Yeah, lots of wires.
But conceptually, it's the same thing. You're clocking. You're latching things back and forth. You're pushing data out from one chip to the next, and then you turn your latch on, and the display, you send the output to whatever your display is, whether it's a LED or a relay and 595s. I've seen them used quite a few times in, let's say, LED cubes.
Oh yeah.
So it's very popular in an LED cube to control one level of the cube directly with a couple 595s or one of these chips, and then basically do a multiple display or multiplex it. And run another 595 to turn on and off transistors that control each level of the cube.
Right.
If that makes sense.
Right. So you're basically making a matrix out of it.
That's right. So a lot of cubes you see X, Y, and Z in the code. Well, X and Y are controlled on one chip and then you control Z by turning on and off transistors.
Right.
And a 595 does not have any trouble turning on and off a transistor.
Right. Now, you were what 595 were you running there?
In the videos that you have, that's a 74 HC 595 from TI.
All right. Yeah, because the one that I had, it was a higher
you've
power
got,
version of it.
Yeah,
Basically
you've got
had,
a high. That's
had
right.
separate drains, drains to ground on the pin for each side of the chip.
That's right. And the last video that we were looking at is just a sync driver version of the Max, the Maxim chip, and here we've got the TI chip. There is a more basic, personally, I think the 595 is the best choice to start off with, because not only can you output data, but you can read data back in, and they're not, you can get 595s for $1.
Yeah, they aren't that expensive. I mean, I found them online. I think I got 5 of them for $5 or so, or it was like $6, something like that. I think.
Yeah,
for a
that's
pack
right.
Of 5, so it was like nothing.
Yeah, they're very inexpensive. There is a 74 HC 164 and a 165 that do the same thing. One of them reads data back. One of them pushes data out, like what we're doing. And they're 40 or 50 cents. But the 595 it's just a better chip. It for the price it does. It's far more functional. Does many more things.
Right. Okay, before we go too much farther, I need to thank our sponsor for this week. Our sponsor this week is Ting, and let's go take a look at the Ting website. If you've never heard of Ting before, it is a incredible, I don't want to call it new because it's been around for a while now, but they're new, I guess, comparatively, phone service, and it's definitely new by concept. Ting is a pay-as-you-go type of service, so you basically do not get charged more than what you use. So if you have paid for one of the other carriers, I won't mention any other names, but if you paid for so many minutes a month and you go over that, you get a penalty, and they charge you big time for anything that is over that what you've agreed upon. Well, Ting isn't like that. If you go over with Ting, they will increase you to the next tier just for that month. No penalties involved, no slap on the wrist. It's all just done all automatically. And the next month you go back to your normal. And what is great about Ting, let's say you think you're going to use 500 minutes a month and you don't use 500 minutes a month, you actually are in the lower tier. They will actually refund you that. So in addition to only charging you what you use over, they will also refund you. This is the first time any company's ever done this with cell phones. So they have great rates, and we'll look at the rate plans here in a couple of minutes. Again, there's no overage penalties, no slap on the wrist, nothing. It's all automatic. And again, like I said, there's credits on light months, so you don't use what you think you are going to use, and you can change anytime you want from one plan to the other any minute. So no penalty, no contracts at all. So you come and go as you please. You put multiple devices on one plan. So other phone companies are starting to do this now, where they have the family plans and you can add a phone and you share the minutes. That's what Ting does. So Ting gives you, it's $6 a month per phone, and then you share the amount of data, minutes, or text that you purchase between all your devices. It fits great for small businesses. There is no fee or limits on the number of usage and the type of usage or anything like that. And they all have all the features you would think, and plus more. So you have your voicemail, your call forwarding, three-way calling, all that stuff. But look right here, they have tethering and hotspotting included in the plan. So many other carriers charge you extra to do that. There's number porting in and out, text messaging, it's all the stuff, basic stuff, but they include a lot of the data features that you pay extra for on other carriers. Again, like I said before, there is no contract. You can start it up this month, and in 2 months you don't like it, or you move, whatever happens, you don't need to have a contract anymore. Maybe you buy a phone for one of your kids and they abuse it and you want to turn it off. There's no problem turning it off. I mean, there is no contract. It's just month to month, basically. And one of the things they are talking about here, and this is something that's kind of interesting, I never thought about this before, is strategically used devices. So what they talk about is, let's say you have your mother's getting up there in age, and she's old enough that she doesn't really like cell phones and doesn't really carry one around, but you'd like for her to have one in her car in case she ever breaks down. For $6, you can put a phone in her glove box that she can use if she ever needs it, and it's only $6. It comes off your plan. So it's one of those things where it's like, it's so cheap, just the peace of mind you get from doing something like that. That's one of the things you can do. There's other things you can do with it too, and you can go through the Ting website and they'll talk about that. So they have a large number of devices, very strong on the Android side of things as well. And this is where it's different from one of the burner phone plans, where the phones always aren't that great. They're really old phones. You can actually get an S3, anything that works on the Sprint network, because Ting rides on the Sprint network. They use the Sprint network for this. So any phone that works on Sprint will work with Ting. You can bring your own device to Ting as well. They call it geek-powered support. I call it great support. If you think you're a geek, that's fine. I guess I think I'm a geek. But their geek-powered support is awesome. If you ever worked with anything with 2CALs, whether it be Hover or whatever, you know about their support. They're very smart. They're very empowered. So if you call up with a problem, no problem at all. They don't have to call the manager or anything like that. They can take care of it for you. They definitely empower their employees. And they have this really neat concept now. This is the same thing with Hover, one of their other companies. They have a no-hold customer support policy. So Monday through Friday, 8 a.m. to 8 p.m., they disable the whole system completely. You do not ever get put on hold. If you call them, the phone will ring until somebody picks it up. There is no machine, no numbers to press, none of these things sending you in circles. And it's just a completely different concept. It's awesome that you get to talk to a person all the time, and there is no hold. As I mentioned before, they do have tons of Android. Their bills are very interesting. The bills are easy to read. There's graphs showing you usage. It's not like those long phone bills you get from the other carriers at all. And like I said before, it's easy to cancel. There is no contract. So let's go up here and let's take a look at some of the plans. This is the amazing part of this. So this is your plan calculation. So let's say you think you're going to do 500 minutes a month, which is $9. And depending on your texting, if you have kids, you may want to do up to 4,000, 6,000 texts. Me, personally, I would be down in the 100. I do use iMessage, but it's typically mostly other Apple users. So I would just say $3 a month. And if I go over it, it goes up to $5 for 1,000. And I can always adjust that on the fly. And I probably would use probably about a gigabyte of data. So my plan for one phone for the month is $42. That's 500 minutes, 100 text, and a gigabyte of data. And if you go over that, it just goes to the next tier for that month. Then it'll drop back down to what you pick. But let's say I want to add 2 phones to my plan. So I come down here. My fee for 2 phones is $48 a month. And it'd be my wife and I, we probably both don't use 500 minutes. We probably don't use 100 minutes other than calling each other. And we don't text each other except for using the messages on our iPhones. So we probably 100 text messages would be fine. And so you can basically figure it out. The price wouldn't go up very much. Our data may go up a little bit more, but I think we'd probably still be fine with 1 gigabyte because we're on Wi-Fi so much. So there's 2 phones. So now you want to add one of your children onto this. Now, in this case, it's up to $54 a month for 3 phones, but with kids, you probably want to go up here like to 4,000 text messages. So that's $62 a month for 3 phones. Again, it's almost an unbeatable price if you look at it from that point of view. And all of the features for the phones. And let's go up here and look at the devices. I mentioned this before. They have tons of devices. So you can also bring your own. You can buy used ones or buy new. So you get refurbished or whatever. And here's the Kyocera, I guess. And LG, these are all smartphones. Here you're getting into the Samsung. Here's the HTC One. They say the one phone to rule them all, although I'm not going to get into discussion of phones. This is the wrong show for that. But you can get the Galaxy Nexus phone right here with a pure Android experience. You can get different types of the Galaxy. There's a Galaxy Note. There's a S3 different color. I mean, it's so many choices out here. And then if you still want just a plain feature phone, like I mentioned before, putting a phone in your mother's glove box in case she ever breaks down somewhere, they still have feature phones as well right here. And then you also can get additional accessories. So if you want to hook up your home phone, you can hook up your home phone right to the box right here. And there's no reason to have a landline or Vonage or anything else. You just strictly do it all through Ting, which is actually, like I said before, it runs on the Sprint network. All right, so I want to tell you also about a special deal that Ting has given us for our listeners and viewers. They have actually given us the ability to offer you $25 off of your first bill or your phone purchase or whatever. And the way you get that $25 is you just go to tech-zen.tv/Ting. And that will take you to the special page that gives you your $25 credit to help you get started with Ting. And that is very gracious of them, and we definitely appreciate their support. So if you're looking for a new phone company, actually, even if you're not, I still recommend you go out and check it out, because I think after you take a look at what your pricing and everything is on the Ting plan, I think you're going to want to consider switching just because of the price savings, especially if you have a large family. All right, let's get back to the show. All right, so is there anything else you want to cover for this week?
Well, I think we've, unless we were going to look at a setup, but I don't think either one of us have a breadboard with a camera zoomed in enough for that right now.
No, probably not. I mean, I have this overhead shot that looks like a mess. I don't know if it really would make much sense to somebody as far as setup goes. You can barely see the pins in there. I mean,
barely see the chips in there.
Yeah, for all the other stuff.
Well, I think we've shown the advantage of using a shift register, and hopefully the comments in the source code is good enough that.
Oh, your comments are very good in the source code.
Well, the goal was to be able to take, somebody to be able to read the comments and actually hook something up and get it to work.
Right. Absolutely. I have on the website from last week the single chip wiring diagram that you can look at, and then I put the two chip one up this week. Gives you a little bit of an idea also how it's all wired up.
Yeah, and the code that's got the NLEDs is actually the library that supports an infinite number of LEDs.
Right. Well, I think that's what I'll link to up on your GitHub.
Well, hopefully we've been helpful.
Yeah. Well, I'm sure we have. I guess we kind of need to do a little bit of the housekeeping stuff here. If you're watching it on YouTube, make a comment down below. Give it a thumbs up, share it with friends, kind of get it spread around a little bit. Comments are always helpful. That's actually how Bob and I met, was he had a comment on the show, and look at him now, he's on the show with me. Hopefully he comes back a couple more times with me. Enjoyed having him, and he's been fun to work with. So
I've enjoyed doing these demos. It's been a lot of fun.
Yeah, if you have other ideas, definitely let me know. I'd love to keep you coming on the show. If you're downloading it on iTunes, go out and put a comment. That definitely helps us get found. Our downloads are growing. Our YouTube views are growing, and it's going to keep that up. Our show notes can be found at techzen.tv/letsmakeit, or now you can go to letsmakeit.tv. Either way will get you there. And on the show notes, you can see all the links to source code or source code and drawings and all that kind of stuff as well. And again, I want to thank Bob for joining me tonight. Definitely appreciate that.
Thank you for having me.
Anything you want to push out there, Bob? What are you working on as far as fun projects?
Right now, I'm revisiting a LED cube, and actually I've drawn the schematic for a Arduino shield.
Awesome.
That'll run a cube. And it's actually using I've got it designed with the 6971 from Maxim.
That's awesome.
So I've got the schematic done. Now I just need to get the footprints laid out.
So what do you use to do your schematics with?
I'm trying something new. I'm not sure how to pronounce it, KiCad or KiCad, the open source schematic editor.
I don't know if I've ever played with that one. I was using, well, I used to use a PC a lot more. Now I use a Mac. I don't know what I'm using. I actually started using Fritzing to do some of the drawings for the show and stuff, and it actually can do some layout. Although its auto layout engine's kind of weird. I ended up pretty much laying it out myself.
Well, I tried this tool because it's now the Mac. It's not officially ported to Mac, but it is on Linux and Windows, and it's open source, so it's free. And Eagle is a good product, but
I used to use Eagle, yeah, on the PC.
It's just too expensive.
Yeah. When I did a lot of PIC development, that's what we used was Eagle because they had all the stuff in there for PIC chips, and the libraries are already in there. It's just easy to take it off and run. And actually, its layout engine is pretty decent as well compared to this. I mean, like I said, I've been using, I think it's called Fritzing. You see, like people do the Arduino stuff, doing stuff with it, and it's okay, but for doing board layout, it's just not very efficient on how it does it.
Well, I was impressed with KiCad. Because there was no schematic available for the 6971, and it took me about 10 minutes to find a tutorial and another 15 minutes to get the schematic done.
Oh wow!
Which is not bad at all for somebody who just sat down in front of the tool, a couple hours before that.
Yeah, how do you spell it?
KiCad.
I'll have to check it out. Does it run on a Mac or is it only on a PC?
There's an unofficial port to Mac, which I'm running Mountain Lion, and I have not gotten it to work properly.
Okay, I mean I have VMs for PC stuff because there's something that I just can't get off of on the PC on my Mac, so I can always go back and do that. I just don't like doing it if I don't have to.
Yeah, I would prefer running everything on the Mac as well, but yeah, you're right, that doesn't always some things you just aren't ported to Mac.
Right. All right.
So,
well, I definitely appreciate your time tonight, Bob, and I hope to have you back on the show sometime soon, maybe a little more regularly, even if you're up for that.
Oh, you bet. This has been a lot of fun.
All right, that sounds good. Thank you very much, Bob. Everybody have a good night. We'll see you next week.
Good night.
Night. For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.